Today we're going to be talking about addition of equations. So first we need to talk about a little bit of vocabulary. Your first term is equation. An equation is a mathematical statement that two expressions are equal. So if we're showing it's equal, it means it has an equal sign. So there are two sides with an equal sign. The solution of an equation is the value, or sometimes values, of the variable that make the equation true. When we say isolate the variable, try that again, it means get the variable alone on one side of the equation by using inverse operations. And we'll talk about what inverse operations means in just a second. So an inverse operation is an operation that undoes other operations. So for example, the inverse operations of addition is subtraction, because subtraction undoes addition. Therefore, addition undoes subtraction, multiplication undoes division, and division undoes multiplication. So those are our inverse operations. So the first thing we're going to look at is using some algebra tiles. And remember that the red ones are, that should say negative, are -1, and the red x's are negative x's, and the positive ones are yellow, and the positive x's are yellow. So we're going to use algebra tiles to first model the situation and then solve. So we have a yellow x, and this is a plus. Whenever we're talking about equations, because of add the opposite, we actually just talk about the sign. So this is just going to be +6, so they're positive, and this is +2. Now, what we want to do is isolate this variable, which means all of these guys gotta go. So how do we get rid of a +6? Well, if you remember our integer stuff, let's see if these are infinite, but they are not. So I will draw. If you remember your integer stuff, let me get, okay, where are you? All right, it appears my computer is running a little bit slow, so let me see if I can figure out where it is. Ah, there we go. Finally caught up with me. All right, so, or maybe it did. All right, there we go. Yay. All right, so I have a positive x. Oh, look, those were infinite cloners. All right, so I'll move this back over here for a second. What I had was a positive x, and I had +6. So I'm going to put those down there. And then we said we wanted to get rid of that +6. So to get rid of a +6, remember we talked about just a second ago that we do a -6. So I'm going to put my -6 down here. And then if you remember your integers and your 0 pairs, these guys right here cancel out. Now, because it's an equation and both sides have to remain equal, please remember that whatever you do to one side, you have to do the other side. So when we drug that +6 or that -6 on one side, we have to do that to the other side for each side of the equation to remain equal. Almost there. So as you can see, what's happened here is I've created some 0 pairs on the other side as well. So these 4 right here cancel out, which means in my last box, I'm going to demonstrate my answer. So I've got an x. And again, remember that x was all that I wanted left down here. So all of these guys canceled out, so that's all I've got left. And that means I have 1, 2, 3, 4 left. Okay, they didn't move like I thought they would. I've got these 4 negatives left that go in this box. So that means my answer is x equals -4. And that should make sense because if we were to take our equation and plug in -4 plus 6, that would equal 2. Now, we're not going to be modeling every single time. Sometimes you just need to know how to do the steps. So I'm just going to draw the pictures in here because it's a little bit quicker than the infinite cloner things that we were using. So I'm going to draw a box for x, and then I'm going to draw a +3. So this is just what I mean when I say model. In the next box, I also have to have my picture. So remember that that was x plus, I think that was 3, yeah, and then 5. So how do I get rid of that +3? Because remember, I want to isolate my variable, which means I need my x all alone. So to get rid of these guys, I have to put negatives, which means I also have to put negatives over here. So this is kind of like the box where you're going to show your work. This is the setup, this is your work, and then in the final box it'll be your answer. So these guys are going to cancel out. These guys are going to cancel out or make 0. And in our last box, we're going to have just our x. And then these are the only guys left, which means x equals 2. Now, I know you're probably thinking, why do we go through all this work? Well, because eventually this gets a lot more complicated and you're going to want to be able to show your steps on each individual one. So on the next one, we have a different type of key where our x is represented by this weird shape. And our +5 is represented by smiley faces. So I'm going to put 5 of those. And then that is going to be equal. So what I'm going to do is to show equal, I'm going to put it on a balanced scale. And this is usually how we represent a balanced scale. And that is the equal sign in the middle. I'm going to put 1, 2, 3, 4, 5, 6, and 7. And that's how you would model that equation. Now, typically, I don't like to put symbols inside my models, so I would really prefer that instead of doing that, that you drew a balanced scale, and then, of course, your cup and your 3, and then you had your 6 on the other side. This is how I would much, much prefer that you model your equations. However, we need to be able to solve this. So there's 2 different ways that you can do this. One is called the crossout method, and one is the way that we've been practicing so far. Do you agree that if this was a balance and it would move back and forth, if I took 1 off this side and 1 off this side, that it would stay even? If I took 1 off this side and this side, it still stays even. 1 off this side and 1 off this side, again, it still stays even. So our 1 cup, our x, is equal to 3. Now, the reason I'm allowed to do that is because removing a positive is like -3. And remember when we did add the opposite, that was the same thing as putting a -3 on, which of course makes 0 pairs. So that's going to be very important in just a second when we start talking about your algebraic steps. So the steps is really the way you're going to majority of the time be doing it. So what you're looking at is I've got x plus 5. So on x plus 5 equals 8, I need to get rid of those positive 5. And if you think about it as your counters, those are your positives. I'm going to get rid of them with negative counters. So if I write -5, adding negative 5. That is actually the same thing as subtracting 5, taking them away. Because remember, subtracting 5, add the opposite. So this is where that inverse operation thing comes in, because subtracting a positive is the same thing as adding a negative, which as long as we cancel it out, as long as we make 0, we're happy. So if I add 5 and then turn around and subtract 5, that all goes away, which I know seems very confusing right now, but we'll come back to it in just a second and do so many examples, you'll be good, I promise. So 8 minus 5 is going to be 3. To check, we write the problem, we plug in our answer, and we make sure it works. All right, how do we get rid of an add 5? Inverse operation, subtract 5. Positive 5 and negative 5, plus 5 and subtract 5, however you choose to think of it, goes away, and we get A. We have 3 and a negative 5. You need to think of these as integers, not add and subtract, because you'll make more mistakes that way. So if we have a positive 3 and a negative 5, we get a negative 2 as our answer. This is why we always want to go and check, because when we plug things in, sometimes we can find mistakes. If we have negative 2 and positive 5, that's going to give me positive 3. The next one, this one's a negative 3. How do you make a negative 3 0? With a positive 3. That goes away, and I've got Z equal to 8, 9, 10, 11. Again, please always plug it in to make sure it works. Oops, I forgot to write my problem. So when I plug it in, I get negative 3 plus 11 equals 8. Decimals are no different. I have add 2/10. I need to subtract 2/10 to get rid of it. Positive 2/10 and negative 2/10 is 0. And when I subtract this one, I'm going to go do a little bit of math over to the side. Remember to line up your decimals. This is 8, 10, 1. It's 1.8. So my answer should be 1.8. Watch your integers. This was a bigger number than this one. So we had more positives to start with, so our answer was still positive. So C plus 0.2 equals 2.08. 1.88 plus 0.2. Does 1.88 plus 0.2 equal 208? Sure does. So our answer is correct. All right, now this one's a little bit different because the G is on the other side. Doesn't matter. We always need the variable alone. So how do I get rid of a positive 20 with a minus 20? This goes away. I've got a G left over. Negative 20 and negative 20, negative 40. Again, always do a check to make sure you did it correctly. Negative 20 equals, sorry, I don't like that. Let me erase. So negative 20 equals negative 40 plus 20. This side doesn't need anything done. Negative 40 and positive 20 is negative 20. So it works. All right, last one. Now we have a plus 5 and a plus 3. Okay, let's do a little simplifying first. Plus 5 and plus 3 is plus 8. Now, how do we get rid of a positive 8? With a minus 8. That goes away, and I get x equals 0. So I'm going to do x plus 5 plus 3 plus, equals 8. 0 plus 5 plus 3 equals 8. 0 plus 5 plus 3 is all 8. So yes, it works. So make sure and look in the next pages of your workbook and practice, show all your steps, and perform a check. It's the only way to ensure that you've done it correctly.